The last lesson we spoke about medians and we looked at what it meant if a line was a median in a triangle. It crossed through the centre of the opposite line and one of the other vertices. Today we're going to look at altitudes. So an altitude of the line is a line through a vertex, so we've already discussed that. That's the corners of your triangle that's perpendicular to the opposite side. So this line going straight up and down here is what we would call the altitude through B. So it goes through the point B and goes through the line AC at a right angle. Now the one across the left hand corner here, point A, going straight across, meeting at the side BC at a right angle, is called the altitude through A, which leaves the one, the bottom right hand corner, point C, vertex C. The line coming from there is the altitude through C. Now where they all meet, this point of intersection here is called what we call the orthocentre. Okay, so we could think of altitude, as it says there on your screens, as being the perpendicular height of your triangle. So looking at this diagram here, you see it's not so many lines, a wee bit less cluttered. The line from B to D is an altitude and BD is perpendicular to AC. We note down there on the left hand side there, this point is not usually the midpoint unless the triangle is isosceles. So some people do end up assuming that D is the midpoint of the opposite side. That isn't. D hits the other side at a right angle, not necessarily the midpoint. So to find the equation of the altitude from B, you would need obviously the equation of a line, which is y minus b equals n times x minus a. So in order to complete that, you need a point B of course, and the gradient of BD. Now we know if we can find the gradient of AC, we know how to get the gradient of BD, because when you multiply them together, it gives you an answer of -1. Okay, so you need both those things before you can find the equation of an altitude. Let's move on then to this example. Remember, you'll get a copy of all your notes when we return to school, but if you do want to copy them down, you can. So this first example, it's got a triangle, 3 points A, B and C. Find the equation of the altitude from A. So the first bit of information there is this from A part, so we know that it passes through point A, 3, -5. So we've got partly what we need. We now need to find out what the gradient of the altitude is. So it's sometimes easier to have an example. So you say if you were to plot it in a coordinate diagram on the right hand side, just quick sketch, that's what it would look like. Sometimes, however, it's just useful to draw a triangle, not an isosceles triangle, just draw any triangle and make the top point of it, in this case A, or whatever the altitude is from. So if it was from B, you would flip that round so that B was at the top, or change your lettering system so that B was at the top, and so on. It just makes it a wee bit easier if you've got a diagram in front of you to visualise and work on. Let's look then how we're going to solve this. So to find the equation, you need a point in the line, so we've already got that, we discussed that. Point A is 3, -5, and then we need the gradient. So to work at PC, we need to work out what gradient of the perpendicular line is first. Okay, so the line joining B and C together, x to your y2 minus y1 over x2 minus x1. You've got the 2 points, so you can sub that in. You've done it 100 times. So the gradient is 1 over 11. If we want to get the gradient of the altitude, which is a right angle triangle, we need to flip it upside down and change the sign. So rather than being 1 over 11, it's 11 over 1, or negative 11 over 1 rather. When 11 is divided by 1, it's 11, so your required gradient is negative 11. The final step there, you've got a gradient, you've got a point, so you're going to substitute in y minus b equals m times x minus a. Keeps coming back to that formula. Work your way through it, and you will end up with line y equals negative 11x plus 28 is the equation of the altitude. Right, let's look at this second example then. So you've got a triangle DEF. Find the equation of the altitude from E, where E is 0 minus 1. DF is equation 3y equals 5x minus 5. Now, it tells us that E is 0 minus 1. The altitude is from E, so your diagram when you draw it would look something like this. And then you're left to run through the steps. So, calculate the gradient of DF first of all. So you've got the points for D and F, or rather you're given the equation of D and F. So you need to rearrange that into the form y equals mx plus c. So really the quick way of doing that there, you've already got 3y equals 5x minus 5. You want to divide by 3 to leave you with y, but you also need to divide the other side by 3. So 5x becomes 5 over 3x, and take away 5 becomes take away 5/3. Now whatever the coefficient is, whatever's attached to the x is your gradient. So in this case, the gradient of this line is 5/3. Next you need to explain where you're going. You need to make sure that if you're calculating the gradient of the altitude, you need to write some kind of statement as to why you're doing it. In other words, you're multiplying the two gradients together to give you -1. So the reason that you're doing what you're doing is because you have that bit of knowledge. So DF is 5/3. Perpendicular line to that is going to be negative 3/5. Flipped upside down, change the sign. So you've now got a gradient of negative 3/5. You've now got a point 0 minus 1, subbing that in. You can work your way down, but once you rearrange it that, you get y equals minus 3/5 x take away 1. Now we're going to do a wee bit of practice on this. So last time is medians, this time is altitudes, and we'll be moving on to the final type of line in our next lesson.